DL is providing breakthrough results in speech recognition and image classification. From this instance, in 2012 paper, TPDN 7 hidden layers CAS 2048 updated state alignment specification. Parameters 45.1, 45.1, 15.2, 17.1, 16.4, 16.1, 19.6, 18.6, 18.5, under this. DNN HMA. So here 12.3, 47 point. Under DNN HMA, MCDNN will come like this, and then relative improvement like this. What is exactly deep learning? Why it is generally better than other methods, than on image, speech, certain other types of data. The short answer: deep learning means using neural network. Several layers of nodes between input and output. The series of layers between input and output to feature identification processing in serious stages, just as for brain seed. Multi-layer networks have been around for 25 years. What is actually new? Long answer. Remember a quick explanation how neural network weights are learned. The idea of unsupervised feature learning, why intermediate features are important, the difficult classification task, and how neural networks seem naturally random breakthrough, the simple trick for training deep neural networks. And f of x equal to 1 by e power x. This is trace. This one input corresponding weightage then a function of x and result comes. Then input, this is input, this is weightage. After substituting this like this, then we will get like this 21.34. Training the neural network. Here class initialize with a random variable. Result training pattern 1.4, 2.7, 1.9, 1.4 to 1, class 0 class. Feed through get output. So then we will get output. Person training pattern. Person training pattern. So, okay. 1 class 1. So, person training pattern. So, point 9 output. Error for minus 0.1. 1. Repeat this 1000 maybe millions of times each time taking a random training instance and making slight weight adjustments. Algorithms or weight adjustments are designed make changes that will reduce the error. Algorithms for weight adjustment are designed to make changes that will reduce the error. The decision boundary perspective initial random weights. So after training like this now it will so like this will come. Like this. See here. Going on adjust present training instance adjustment rate adjustment the decision boundary perspective adjusted present training instance adjusted weights. Moving on now going like this eventually like this. Yeah. So separate this one separate. The point I am trying make eight learning algorithm for neural network are dumb. They work by making thousands and thousands of tiny adjustments, each making the network to better at the most recent pattern, but develops a little worse for many others. But by dumb luck, eventually this tends to be good enough to learn effective classifiers for many real applications. Sorry. Some other points. Some other points. Details of standard error weight learning algorithm. Weight learning algorithm. Later, if a person is non-linear, then network with one hidden layer can easily learn perfectly any classification problem. A set of weights exists that can produce the targets from the inputs. The problem is finding them. Some other binary points. If f of x is linear, the neural network can only draw state decision boundaries, even if there are many layers units like this. some other by the way points. Some other by the way points. If fx is linear, the neural network can only draw state decisions. Boundaries even if there are many layers in it. If fx is linear. Some other, if fx is okay, then the neural network is non-linear. F of x. So they can draw complex boundaries, but keep the data unchanged. Simple wave machines only draw straight lines, but they transform the data first in a way that makes that okay. Okay. This is non-linear. I have handwritten physics from postal envelope. Features decoder, input layer, hidden layer. Hidden layer become hidden layer units become self-organized feature detectors. Hidden layer units become self-organized feature detectors. 1 to 25. Strong plus positive weight divided by low zero weight. What does this unit detect? Strong plus positive weight divided by zero weight. Strong signal or disk or dark area in the top left corner. Examples of handwritten digital from US Postal Service. What features might you expect a good neural network to model when trained data like this? So vertical lines here. These are vertical lines. These are vertical lines. Here also in 4 also vertical line, and the 9 also vertical line. Examples are handwritten physics. Small circles, horizontal lines, small circles, 2, 6, 9. But what about position invariance? Our example unit the detectors were tied to specific parts of the image. Successfully can learn higher level features. 1 to 25. Detect lines in specific position. Higher level detectors, horizontal line, or which is vertical, line, upper look, etc. Multiple layers make sense. Your brain works that way.